Hello, hello. Welcome, everyone. Welcome to the Capgemini Build Tech Talks. My name is Wishi. I'm the evening. We have two tech talks online for you. The first session will be presented by Tom. He will talk about the wonders of web components. And the second session will be presented by Maarten. I'm going to wave to him. Hi. He will present implementing web components. But before we really start, I want to announce two things. So let's start with the most fun part. As you can see, we have a nice, comfy hoodie here that you can win. And how you can win, we are not going to tell that. You're going to hear that about at the end of this tech talk. But I can give you a small hint. And the hint is listen carefully to the tech talks. So, let's continue actually. I have, hang on. One side note, I forgot about it, is if you have any questions, you can drop them in the chat here. At the end of the presentation, we will, I will ask these questions to the presenters. So, right, let's move to Ton. Ton is here with me.
Oh.
So, I have a small question to start with.
Yeah.
How did you come up with web components as a subject?
Yeah, I've worked with them quite a lot in the past years with different big projects, and I think the fact that you can use them in so many different use cases, so that every time when you work with web components, it's completely different again. I think that's a beautiful thing. So it never gets boring to work with web components, basically.
It's very interesting.
Yeah.
Well, I'm going to give the floor to you. So let's go.
Yeah, thank you. All right. Well, welcome everyone to this intro session on web components. Today I want to take you along in the world of web components. You will find out what web components are, how they are built up, the ups and downs, and of course I also want to present you with some use cases. And after that, to top it all off, I will code a web component to show you how easy it actually is to set up a vanilla web component. But first, let me give a short introduction about myself. So my name, as you already heard from Wishi, is Ton Oordijk. Started at Capgemini as a junior front-end developer on 1.1.1.1.1. So quite a while back already. In multiple different large projects at big financial institutions, I grew towards the managing software engineer that I am today. Currently, I'm building some cool front-end stuff at ING, and of course, I'm using web components over there. Then a little bit about my personal life. I live in Leusden together with my fiance and my two cats, and in my free time, I love sports. Both doing sports, as you can see in 3 of the 4 pictures on this slide, but I also like to watch some sports, which is the 4th picture, and I'm going to leave it up to you to spot the picture where I am actually watching sports. Well, now you have a better idea of who you have in front of you. Let's first dive into the history of today's topic. So I made a short timeline, starting with in 1998, Microsoft actually started implementing a way to extend the DOM by adding attributes that could change the behavior of the default HTML tags that already exist. Since it was too complicated to use, and therefore it was abandoned actually by Microsoft itself, and it was not supported anymore from 2011. Separately, Mozilla tried to have a similar approach as Microsoft did with Mozilla XML binding language. This approach was actually closer to the web components that we know today, but the implementation was quite poor, and it was only working in Mozilla products, and therefore Mozilla discontinued this language in 2012. Then starting from the year 2009, large JavaScript frameworks like AngularJS and React actually started popping up. They tried to implement the component idea in a way where it would work in all browsers. Up until today, we all know the big JavaScript frameworks that can be used to create complete applications with the component mindset. And then in 2012, mainly driven by Google, the first version of the Web Components Specification was released. The goal of this specification was to have standards for setting up and using web components in any browser without the need of external libraries. Oh, wrong button. Looking at the Web Components specification, what is it? It basically is a meta specification which contains 4 different other specifications. The Custom Elements specification, the Shadow DOM specification, the HTML template specification, and the ES module specification. In the next slides, I will go deeper into these 4 different specifications. First one, the Custom Elements specification. This gives us the possibility to define new custom HTML tags. After defining it, it can be placed anywhere in the DOM, as you would actually also do with the normal HTML elements. The Custom Elements specification is a cross-browser standard that does not need a library or framework to work. And what is also good to mention here is that since it's a standard that all browsers implement in the same way, existing accessibility features, for example, can be leveraged out of the box. The next part of the Web Component specification is the Shadow DOM specification. The global nature of HTML, CSS, and JavaScript can cause issues when web apps get bigger. When creating a new class or ID on your HTML tag, there is no way of knowing this class or ID is unique in the entire DOM. Next to that, CSS specificity becomes a big issue, causing style selectors to grow out of control, which in turn can then hamper the performance. The Shadow DOM specification was actually created to fix exactly those issues. It introduces the possibility to scope your styling and hide the implementation details of your custom component. This makes it possible to use a web component wherever you want without having to worry about naming collisions or styling issues. Then over to the HTML template specification. The third specification that is part of the web component specification. All the big MVC frameworks, as I just mentioned, like Angular, React, Vue, they implement some form of templating for the rendering of their views. However, they all do it in a slightly different way. Well, since most developers are as lazy as possible, there was a desire for a standard for reusing pieces of HTML. This is where the template element from the HTML template spec comes in. This element makes it possible to declare fragments of markup, which are parsed in HTML, but actually stay unused on page load. So at any moment at runtime, the template can be initiated so that the DOM is only filled with HTML that it actually is showing at that moment. And last but not least, we have the fourth specification, which is the ES module specification. In bigger web applications, splitting up the view in components become more and more important. You want to keep your code and your files readable and small. To achieve this, the ES module specification was introduced. In a nutshell, this specification defines the inclusion of JS files in other JS files. At client side, ES module files are actually merged into one big file, so that they only have to load one file. But with build tools like Webpack, for example, you can also do that ahead of time, so that the browser doesn't need to do that. Merging, on runtime, basically. Yeah. All right. So now that we know what web components are and what they consist of, it's about time to look at the pros and the cons. So let's start here with the pros. With web components, both the functionality as the styling of your view are scoped. This means that you can place the components anywhere on a page without affecting the other parts surrounding it. This also causes web components to be very well shareable and reusable within big organizations, because if you have a lot of different applications, then you can use your web components anywhere you want, and it will all behave the same way wherever you place it. For creating and using web components, no third-party libraries are required. The web component specs are implemented in all major browsers so that you don't need anything to run them in your browser. Maarten will later on explain why, despite of the fact that it's not really needed, it would still be beneficial to use a library for setting up your components though. So keep posted for that. All right, next one. Using web components make the template code really readable. To give an example, if you're looking for, let's say, the footer in your template of your entire big application, normally, you would probably be looking for a series of divs with footer classes on it, for example. But with having a footer component in there, it's actually really easy to spot the location of this footer in your entire template. This also makes the coding with web components feel really natural. And then last but not least, you can deliver functionalities without complex dependencies. So if you, for example, build a component using React, including them in an application would always mean that you have to include the complete React library as well. With web components, this is not the case, since they don't need a third-party library to actually work. Then over to the downsides, which are obviously also there. Since web components make use of the shadow DOM, SEO will actually take a big hit by using web components. It's harder or sometimes even impossible to let your website be crawled by search engines, which can have a big impact on an organization, because if you cannot be found on Google, then let's say you don't exist. Next to that, it's not possible to share styles properly between web components. Since the shadow DOM almost does not let any styles bleed through, they cannot be used by other components. This could be solved by having a generic styling package, for example, which is used in all the different components. But since this is introducing an external dependency again on the component, it's not really an ideal situation, I would say. Then another downside is the initialization speed of web components. Well, since web components have to be registered in the browser using JavaScript before it can even start thinking about rendering itself, there is some delay in the first paint. Then the last point I want to mention here is, it's becoming less of an issue lately, since more and more people are actually adopting web components, which is of course really, really cool. However, compared to the, let's say, big frameworks in the front end, the community and support for web components, especially in the edge case scenarios, is really still an issue. This causes organizations to need a certain level of seniority, since some issues have to be sorted out without any help from the internet, because nobody has encountered it before or nobody wrote about it. A good example of this actually was an issue we faced with web components inside a project that I did at one of the biggest banks in the Netherlands. There was not a lot to find about that issue on the internet, so in the end we just had to construct our own solution to make it work, since it seemed that there was not really an out-of-the-box solution for the issue we had. So in that case, it can actually take more time to develop a certain scenario, because there are some issues that are not happening for other people yet. All right, since now you're all experts on the topic of web components, let's look at useful and less useful scenarios for web components. So when should you really consider using web components? Well, first of all, if you want to create a library of reusable components, which is less likely to get redundant or unusable, go for web components. Since web components are framework agnostic, they can still be used if your organization, for example, chooses to switch to a different front-end framework for their applications. If they move from React to Vue, for example, then your web components will still work. The second point would be that if your organization is using multiple different large frameworks in their organization, which is most of the times not a good idea anyway, but if they would do that, web components can actually really help you, because they can freely be shared between all the teams, regardless of what framework they are actually using, because yeah, they have no impact on the functionality of the web components. So you can use them in all situations there. Then the last point where it would be useful is that if your organization has a desire to not use a framework at all, it is even possible to create your entire front-end application landscape using web components. You are probably going to need some extra investments in time to actually have things like store management up and running. But yeah, I would say the sky is the limit. So if you want to invest some time in it, it's very much possible to not use a big framework and just use web components as you like. Then over to the use cases for which web components might not be the best choice, because I don't want to be the biggest supporter of web components here and say everyone should use them, because there definitely are scenarios where you really should not want to use them. For example, if SEO is a really big deal for the application that you're going to build, don't go for web components. They're just not equipped to have SEO optimized to the max. Next to that, if your organization puts a big priority on having the first paint as quickly as possible, web components will not be as quick as using, for example, plain HTML or optimized server-side rendering. Then these would probably be better options to go for. Then the last point would be that if you're building one single application where reuse is not really possible or not really needed, a larger front-end framework or maybe even server-side rendering might be a better choice for you, because it just brings you more out of the box and it's just easier to build your application completely in that way. All right. Then let's dive into some code. Oh, my mouse is over there. I see my mouse 2 times. Oh, that's nice. All right, here we are. So what I'm going to show you is actually I'm going to build a counter component for you completely in JavaScript and HTML. So I'm not going to use any library for that. So just a vanilla web component. And when I actually build that component, I'm going to use that component in 2 big frameworks to show you that you don't need to do anything extra to be able to use web components in big frameworks as well. So the first thing I will do is I will just create an index.html. I will increase the font size because otherwise no one can read it. Well, I hope this is better. So we will start with an index file which is completely empty. And then the only thing I will add is our nice web component. So what I added here is just a simple button and my awesome counter component. So as you can see, it doesn't, my editor already doesn't recognize the HTML tag because it obviously isn't an HTML tag. But this is just a web component. Well, if I'm now going to open this, then we can actually see that the button is here. My web component or my something element, which is not something yet element, is actually already visible in the in my developer tools. But yeah, obviously it's not on the screen yet because we don't have anything for it yet. So what we will do then is actually add a script tag where we are going to load the JavaScript of our counter component. And I will add the JavaScript file, which is going to contain my, Let's see if I can increase the font of this as well, which is really hard without a mouse and a keyboard, but I think this is already better. So what I will do first is I will just create a clean web component, which is basically this. So we have the template which we are going to create here. So this is from the HTML template specification that I talked about earlier. Actually, now I think of it. So this is basically the ES module specification part. So we can actually include JavaScript files in here. So this is the smallest thing that you can actually add, and that it already is a web component. So what I can now show in the browser is if I actually reload it, nothing changed because I still did not add any HTML to my component. But what you can see here is that it actually has a shadow root now. Well, there comes the shadow DOM specification into play. So this is already quite nice. So it's a really small amount of code, but we already have built our first web component. But it actually doesn't really do something yet. We don't see anything on the page. So let's add an actual template. Well, this is quite big, but at least it's readable. So basically what you do, you create your template element. And what you then say is that the HTML within your template element, just put in, in this case, a style tag with some styling, which is not too important for now, and some HTML. So we have the slot tag here, which I will discuss later. We have a simple button, a span, where you actually start with a number, and another button. So if we go back to the browser now, the other way, is, well, we have our beautiful counter component, which what is really important to actually notice here is that we have buttons here and we have a button here, but this button is actually styled because we added the styling in our template, but this button just looks the same as it already did before. This is a perfect example of how the shadow DOM works. So if you give styling to a certain element, it only contains in that single component and it will not go outside. So if you use this somewhere else, it will not hamper styling of whatever is surrounding it. To even further show that is I can actually add some style to the button we have surrounding. Oh, as you can see, I gave it a color cyan. This button is now actually this color, but the other buttons didn't change. So it works two ways. So it's not going upside to the other button, but also not into the component. So that's really important to see. Well, but now we have our really nice counter component here. But if I click here on these buttons, it's not doing anything. So let's try to make sure that it's actually going to start doing something. Well, Maarten is probably going to show later on how you make listeners using a framework, but it's also quite simple if you do it with vanilla JavaScript, because it's basically just two lines where you are going to look for the element, and on the onClick method, you're actually going to increase or decrease the. This is too big. Now you cannot read it. Better. So for this, I will also add the proper methods, which is basically just an increase method where you update the count number with a number which is one higher than before, and the same for decrease. And here it actually changes the count, which is 0 at the beginning. So now if we go back, oh, nice, it works. can even go below 0. So this is really, really cool. The last thing that I would really like to add to this is a title, for example, because I want to have some text above it. Well, I already mentioned the slot that I have placed right here. And the slot is basically just a place where you can put in whatever you want. And in this case, it's a name slot. You can also use a slot without a name, and then it's whatever you put between the brackets of the of your custom component. It will be placed in this slot. So I have a named slot here. So in this case, I really have to mention in which slot it should actually place this. So I placed an h2 tag in this slot. And now you can see that there's actually a title above our counter using the slot. And this makes it really, really reusable because you will always have the counter, and that is not something that is going to change because it also has to work in the same way always. But I can imagine that per use case, you might want to use another title, for example, if you want to put something else in there, and then slots is a really good way to implement that. All right, so now we have our really nice working counter component, which is completely built only with HTML and JavaScript. So there's no framework involved in this case. However, what I want to show you actually is that if I have prepared, so I'm already in the React app. So if I start up the React app that I already prepared, because installing it, I didn't want to bother you with that. So this is just a basic scaffold of a React project that you get out of the box. And I'm going to show you that by adding 2 lines of code and actually copying this file here. And normally, probably in the node modules, you will have your components which you can include then from your which you can actually include from your node modules. You will use that in your application. So I'm not sure if I cannot make it bigger. So yeah, it says components here for those who cannot read it. Right, so then I go just simply to the app.js. This I can make bigger. So this is the basic scaffold. So the only thing I need to do here is actually import from the components folder the JS file that we have just created together. And then the only thing I need to do is add my awesome router as an HTML tag. And it's going to compile. Did I make a typo? I'm going to restart the server, maybe that helps. Of course, this doesn't work if you're going to demo, so the demo gods are not really its counter. This works better, yeah. So close. All right, so as you can see, I just included it here, only added 2 lines. I added the import and I added the actual HTML element, and it works out of the box. One thing important thing actually to mention here is I said before that styles would not bleed in and out of a web component. there's actually an exception that I also encountered while preparing this demo. As you can see, the color and the size of this text is somehow different here than it was before. The reason for that is that if there is on a higher level is something related to fonts declared, and you don't explicitly tell the component that it should be otherwise, it will actually inherit the styles that it got from outside of the component, because that's basically just in the CSS specification, the standard setting of, for example, the font color and font size. So if you don't set it specifically, it will actually update. So that's really something to keep in mind if you are working with web components. Then after that, I also wanted to show you that in Vue it works exactly the same way. So we're going to run our Vue instance. Within the components folder again. And the reason that I need to add it here is because for sure for React, I'm not entirely sure about Vue, but they don't accept using JavaScript files which are not in the source directory, unless you explicitly tell it it's okay. But for this case, I thought it was easier to put it in the components folder, since normally you would probably use it from such a location anyway. So we have it here. So here again, the only thing you have to do is do the import of the counter component. Now I'm typing it correctly this the first time, I think. Bigger again. So import and use the HTML tag is basically all you need to do. And then we go here, and you can see again, so it takes sort of the font styles that it gets from the Vue scaffold, but here it also just works out of the box. So this was basically what I wanted to show to you today. Thank you for joining this first session about web components, and I would say let's see if there are any questions from the audience.
Right. Thank you for the presentation. It was very intriguing, and I think along your talk, you said we're about to get to be experts.
Yeah.
Yeah.
That's at my hope, but experts that will probably take everyone years, because
well, I think you can call yourself quite easily an expert on a lot of things. But
I hope so.
But that said, I've checked the comments, but I haven't seen any questions. So I'll come up with a few questions. So are you ready for it?
Yeah, shoot.
So the first question, I was interested in real life examples where they use web components. Do you have a real life example that you can share with us?
Yeah, I think the amount of companies that work with web components is growing and growing. Also, a lot of our clients at Capgemini are actually working with it, and I think a really good example is, for example, ING, where they also open sourced their own component library, which is basically just a web component library. So I think that's it's really cool that they did that, and that's one of the best examples I can give about that.
So it's really open source. Everyone can access it. And
yeah.
Okay, that's really interesting. Another question, maybe not related to this question, but can web components easily share data between each other?
Well, I would say it's not as simple as it would be with the bigger frameworks. There's a reason that the other frameworks are bigger, because they need a lot of code to actually make these kinds of things possible. It is possible, but most of the times it will happen with event bindings. So you can use attributes to sort of give data down to a web component, because on the HTML or the custom tag that you create, you can actually give attributes, and then you will have that data available within your component. But for the upwards data communication, basically, you will probably have to use events.
Events.
Yep.
Okay.
Yep.
Okay. Interesting. All right. Well, I don't have any questions, so I would like to thank you in presenting the Tech Talk.
You're welcome.
I would like to move or continue with the second session. Maarten is here, and he will talk about implementing web components. So I would like to give you the word. So the stage is yours.
Okay, thank you, Wishi. Hi, everyone. Unfortunately, I'm back at home because I tested positive to COVID, or else I would have been in the studio. During the test, there seemed to be some lag between the studio and my home office, so we'll try to make do with the on the technical side of it. I think everything will work out fine. Okay, so hi, my name is Maarten Dekker. I've been working for Capgemini for a little over 2 years now. And before that, I've been working within web development for almost 2 decades. So I was, well, almost at the start of it. When I started programming, CSS was not invented yet. So that's how old I am. Okay, so when I'm not working, I like to do a little DIY, do it yourself around the house. I like gaming, obviously, and reading books. And I play the bass guitar in a plethora of bands, which is awesome to do. Almost as awesome as creating web components. What what we're going to do is, because Ton has created such a great web component, I'll be recreating it, as you will, in a couple of frameworks. We'll have a look at lit or lit elements, and we'll be taking a look at Stencil Js, which are both frameworks for creating web components. And then we'll be implementing them as well. We have a React application kind of similar to what Ton has been showing, and we'll have a look at some Angular, and we'll have some fun throughout the process, I guess. Let's see what we can come up with. Okay, so there are a couple of shared files. It's not too interesting for now, I think. So web component frameworks. As Ton has showed us, it's really pretty easy to create a web component. It's really easy to implement it in your web page or web application. But what if you have 10 web components or 100 web components? Those are a lot of JS files you need to import into your application. You need to figure out which web components you'll be using. So which files do you need implementing in that web page? This is where a framework can make a difference. Not only for this, but also because a framework really takes a lot of the boilerplate away from you. So you can just focus on creating your web component. So as I said, we'll be having a look at lit elements, and after that we'll be looking at Stencil JS. Lit elements is actually, I believe it was created by Google, but I'm not really sure. That is because this is not a history lesson, but it's more hands-on. So let's move just right along. I'll make use of openwc.org. which is a library that can create lit elements web component and really do all the scaffolding and creating the basic files for you. Lit is like a syntax as well, and with OpenWC, which sounds a bit weird in Dutch, but bear with me. Can create all the boilerplating for you. So you can npm init OpenWC. It'll come up with a lot of questions like, would you like to use TypeScript? Would you like to use CSS or SAS or less? Stuff like that. And then it'll implement it. I've already taken the liberty of doing just that. The only thing I did was init the OpenWC and answer a bunch of questions, so we don't have to wait for the npm install that comes after. Okay, so this is the directory I've created. It has a demo in it, which is just an index HTML file, and in the HTML file, sorry, there's a div with an ID of demo, and then there's a script that's rendering the my awesome counter. I'm sorry, I called it my awesome counter and not Ton's awesome counter, but I'm sure he won't be mad about it. So if we have a look at this, let's cd into the directory. And run it. I'll have to wait for a bit. So this is the HTML, and here the awesome counter JS file is loaded. It's under the source directory, which basically has an export file and a web component class. This is called my awesome counter. It has some CSS in here, which is well, a pretty unique syntax for lit. And we'll have two properties, a string and a number, and some basic HTML. But of course, we'll be using Ton's version of it. Let me see if I can put this here. Okay, so this is it. This is the basic web component that OpenWC made. It's also called my awesome counter. I haven't done anything about this yet. This is straight from the init script. So let's do something about it. I'll get the code here. Because I can't seem to do it between the functions. Okay, so let me put this here. It says here, I don't know about this count. That's true. We have a counter. We're not going to be using a counter. We're calling it count. And use this one. Let's get rid of it. We don't need the string. Let's get rid of it. And we also don't need the CSS. We'll create our own. So let's get rid of this. I'm going to save it so prettier makes it easier to read. Okay, so we have the CSS. I copied this, by the way, from Ton's web element. It's in GitHub, so I took the liberty of stealing this. Of course, I'm going to need these methods here, or functions, as I call them. Okay, so Basically what this does, this is the syntax of lit elements. It says here on click we perform the on decrease method, and on click on the increase button we do the on increase, which basically just increases and decreases the count. The count is a property that we have here. It's a number and it's displayed right here. So let's see what that does. Well, what do you know? It's here and it's working. That was pretty quick. All we did was add some CSS. We put in the buttons and the span, and we added a few methods, and we have the exact same web component that Ton has made. This is pretty awesome. Lit elements is awesome. Stencil is awesome as well. So let's have a look at that. And when we're using Stencil, we'll be diving a little bit deeper. What was that? So let me get back to the presentation for a bit. Stencil Js. The only code you need to start using Stencil is npm init stencil. Same as OpenWC, you're going to get a bunch of questions. Would you like TypeScript or JavaScript? Would you like testing with it? Stuff like that. And all you have to do is yes, no, yes, linting, yes, please, ESLint. And then it'll set up some stuff for you. So let's have a look. This is what it built. We have a source here. It has a components directory. Let me stretch this. Stencil already figures you're going to be wanting more than one component. So let's put them all in the components folder. And because I initted the basic stuff, really, it just created a my component. In Stencil, the CSS and the TSX TypeScript, it's like JSX. It's a bit of a React kind of coding. It uses JSX. That's why the extension isn't TS but TSX. But it's putting all this in separate file. So if we have a look at this one, then it says, hello world, I'm Stencil, don't call me a framework, JS. I'm sorry, I just did. I won't ever do it again. Okay. So Stencil's not a framework. Okay. Let's make this into the same web component that we've just seen. So in the CSS file, which now has some stuff in it, we just put the same CSS as we put in the lit element before. We have a couple of properties here. We don't need any of them, but we'll rename this count and we'll make it a number. And we can default it. Why not default it to 9? So we can see how that's working. Okay. We don't need this one. We do, however, need some JSX, which is basically HTML. Stencil HTML, this is the one. Okay, so this is the same HTML that we used for the other component, only the syntax is a bit different. And well, basically it looks like JSX, it looks like a React. And it almost is. So we need to get the function in here as well. Let's save that and reformat. This is looking good. It says here we have a problem. Yeah, we don't need this. Default, you get a utils folder with some utils. This is how to format the name, the first or the middle and the last, and concatenates it. I guess you would call it, but we don't need it for our little counter here. Let's have a look. Yay, it's working. There's something weird here though, because one of the buttons is supposed to be red. Why is that not the case? Decrease ID. That's pretty weird. Well, okay. I'm sure we can figure it out. I don't think it matters too much for now. Just the fact that it's not working as well. So here, something's wrong here. Okay. We have the property. We have everything we need, I guess. Everything is saved. And as with the presentation of Ton earlier, if something is not working, just stop it and start it again. What do you know? It's working. And this is working as well. Okay, weird. I don't know what that was. So I want to show you some cool stuff. So this is the my component. It's not called my awesome counter here. It's called my component. We can change that if we want. Here is the tag name, and here I can call it my awesome counter. And then in the index.html, all these properties we don't need, get rid of them. And then call them my awesome counter. Wait. Still working. And now it's called my awesome counter, just because we told the component that its tag name will be my awesome counter. That's pretty interesting, right? Okay, so we default it to 9, the count here. It's displayed same as the other ones in a span with an ID of count, and it defaults to 9. When we click the button, it increases or decreases, but it says here it's a property, which means that we can provide it here. Wait, so now we say we want a my awesome counter, but the count is 3. And there it is. It's 3 out of the box. It says here count is 3. And if we open it up, we have the shadow root with all of the interesting stuff inside it that we've seen in Tom's example as well. So what happens if I click this button? It says here that it's 5 in the shadow root. And when we get here to the span with the ID of count, it says 5. Yes, it's 5. It's supposed to be 5. Why does it say it's 3 here? It's not 3. That is because it's not reflected. We just use it as an input and it's never outputted again. So if we go back to the component and say here, this property here that we have, we want to reflect it. That means that it's reflected here as well. If all's well, and it's not. Okay, it is. I had to refresh for a bit. So this can be very interesting. As Wishi just asked, how about data transferring between different web components? You can't really, because everything is encapsulated within the shadow DOM. Every component has its own unique space where stuff exists. However, you can use this count here to get it, basically. So if we copy the JS path and go to the console and paste it, this is the component that we do. If we want to output count, it says here it's 6. Change it a bit, and it's 3. So this basically is the same as, for instance, get attribute. Whoa. Count. That's also 3, but now it's a string. Because it's an attribute, and attributes are always strings. So because it's reflected, we can just target this variable, or if we don't know what variable it is, we can just have a look at the DOM and say, hey, there's a count of 3. Then we can just target it and have the information that's within the component and use it somewhere outside of the component. It's really useful if you're creating forms, for instance. Okay, so what if you want to interact from outside the component with the component, or the value of the component in this case? Well, we've seen here that there are 2 methods. One is onIncrease, and it's supposed to increase the count. Well, that's awesome. Let's have a look. Let's call the counter and then say on increase. That's not a function. This is not working. This is because the on increase function is private. And if you want to create a method, a function or a method that you need to have accessible from outside the component, in Stencil, you're going to be using a method property. Let's have a look if I still have this somewhere. So I need to import the method. Oh, there's no quick fix. Of course there is. Yeah. We update the import from Stencil core. So method is imported so we can use it. This is a decorator. And the weird thing about this is that whenever you have a method that's supposed to be available from outside the web component, it's going to be asynchronous. You need to mark it as asynchronous, even though it's pretty easy. This is almost instantaneous. I don't know. That probably a very good reason for it. I'm not aware of it. Okay, so we have a function invert, and what it does, it takes the count and then multiplies it by -1. And if we save this, go back to our browser, let's clean this up a bit. And we know the on increase is not working. Let's have a look at invert. It's not working. I think I need to refresh again. That is working. Okay, it returns a promise. That's fine, but it's inverted the count, and everything else still works the same. So if you need to access a web component from outside of the component, there are, of course, different frameworks. Use different syntaxes for this. This is the way Stencil does it. Stencil, again, it is not a framework. It is not a framework. But if you want to use Stencil, just put method above it, make it asynchronous, and then you can access it from anywhere, which is pretty awesome, I think. Okay, well, I think that shows a little bit more about web components and how easy it is to create a web component within frameworks or not frameworks. Let's see how we can implement this within, I'm going to have to go back to the PowerPoint. Okay. To implement it in frameworks. We've already seen Ton implementing a web component in React and in Vue. I'll show you basically the same thing again, because when you see it again, you actually start learning. And I'm going to show you in a different way. So, implementing web components in your application or page. There's, of course, first of all, the basic HTML and JS. Let's go back, which will show very briefly. I think we've seen that already. React and Angular. Okay, so if you need to incorporate a web component within an application, you of course need to load the JavaScript and CSS. CSS is most likely incorporated into the JavaScript in the web component that we've seen from Ton, and also in the stencil and lit components that we've just seen. The CSS is incorporated into the class that creates the custom element. So it's in the JavaScript file. However, you still need it. And the second thing that's needed to make use of your web components is to make that component accessible within your HTML. Okay, so we've seen this from Tom. You need a script that loads the myawesomecounter.js. And actually, what didn't happen, but what probably was already in the myawesomecounter.js, is that you need to define the custom element to the window. So the window knows whenever I see a myawesomecounter, this thing here with the dashes in it, HTML tag, custom element, I'm going to be using this class to show it. And once you've done that, you can incorporate the custom element anywhere in your page. So that's pretty awesome. We've seen it. We all know how cool it is. Okay, so if we use the Stencil Js component that we just created with the invert method in it and the reflecting property, obviously you're still going to need the JavaScript and the CSS, and you have to make accessible in your HTML. But again, what if you have 100 components? Do you need to import 100 JS files? Do you need to figure out which one you use on the page? And if you use 12, you have to get the correct 12 JS files that you need. It's a bit of a bummer. It's not really useful. If you want to change anything in your page, you need a different component. You have to go through all your imports again. Why not make a package of it? This can be a bit frightening at first, because you can just create an npm package that is going to be available for anyone. Well, it doesn't have to be npm, can be other repos, but npm is most likely the most simple one. And then you just need to import the modules, or in this case, at the bottom, you can also import the no module, just a basic JS script, and import the entire thing, and that'll work. Okay, so package. Yeah, the BLDWC stencil component that we just created. I've created earlier than today, and I've published it to npm. And you can find it at npmjs.com/package/BLDWC stencil, which means that if we have a React application, we can use a create React app. We call it BLD app React, which will give in the beginning exactly the same thing that Ton has showed. And then we can npm install BLDWC stencil and use the entire library. Of course, this entire library consists of one component, but you get the idea. So what do you need to make use of the components in your React application? Well, you need to import the two methods that are supplied by Stencil. They're in the loader subfolder of your package, and they're called apply polyfills and define custom elements. And you can see here how it's implemented. You apply the polyfills, and after they're done, then you define the custom elements to the window. Okay, well, let's have a look at what that's supposed to mean. Let's clear out everything here. Let's stop this one. Yes, please. And go back and up into the app React. And then we do npm run start because I already npm installed it, of course, so you don't have to wait for it. So here we are, the BLD app React. It's created with create React app. And as you can see in the package JSON, we have BLDWC stencil here, version 0.0.7. Nice. Okay, let's see if this has started running. Not yet. Let's have a look at what Ton has already showed. Oh, there we go. Hey, it's the exact same create React app that Ton has created before he implemented his web component. And now we'll be implementing the web component not by importing a JS file, but by using the npm package. Okay, so we have a source folder, we have the app.js, and this is the entire page. We see here, I believe this is where Ton incorporated the web component, so let's do that as well. And here we have the index.js, and well, these change every now and then. I haven't seen these report web vitals before because I haven't used create React app in a while, but well, here it is. Okay, so what did we do? We had to import the polyfills and define custom elements from BLDW stencil loader, and then when everything's done, we need to call the polyfills and then define the custom elements. Is this it? I think this is it. Okay, well, let's have a look. Awesome counter. Let me see if I can do this in one go. Yeah, I can. So there it is. So if we ever have a package that has more than one component as we do now, it's the same thing. You just import the stuff from the loader supplied by Stencil, and this is the code that you need to put in somewhere in your code, and you can just use them anywhere, anytime. I think it's truly awesome. And again, this is exactly the same thing that we had before. Let's copy the JS path, go to the console and see if the invert is working, for instance. And it is. Awesome. So that's really easy. Let's close this one. Let's close this one. And let's have a look at how we can also get this done in Angular. To me, Angular has a bit more steep learning curve than React. I'm not sure how you guys feel, but actually Stencil is a lot like Angular. It's somewhere between React and Angular, somewhere in between. Okay. So basically what I've done here is, well, sort of the same thing, I'm sorry. ng new BLD app Angular, which is going to create a new Angular application. And again, we install the Stencil component. And we have to define the custom elements and import them. So this is a bit different. This is a different syntax. It's called different actually. From the Angular core, you need the custom elements schema. And from the BLDWC stencil / loader, you need to define custom elements. And apparently we don't need the apply polyfills because that's what Angular does for you. Well, that's nice. Let's have a look. Close all this. I have here the totally clean Angular application. Let's go into the directory. npm run start. I don't know if any of you have worked with Angular a lot, but if you do this, they have a pretty hefty default page when you start your first application. Well, let's wait for that for a moment. Okay, so here's the source. We have the app. We have some routing stuff. We have an app module. And we have the component, one component. The first component. Angular uses components as well. It's not a web component. It's a component. It's an Angular component. We're not going to be using, yes, we are, because this is the HTML, which we'll see in a minute. It's a lot. And we're going to be making some changes in the app module.ts. This should all be very familiar if you're used to using Angular. I know Wishy is, so I hope I'm doing everything correctly. Okay, let's open the 4200. Here it is. Look at that. I like the React app. It just gives you a little animation which says, yay, it's working. This is, well, a lot of bother actually. Let's get rid of it. So we go into the app component.html. I have a very big type at the moment, so all of you can see. Let's just leave all the styling there. Okay, let's get rid of everything below the resources. Wait, was that below? Yeah, welcome. Okay. Resources. Let's get rid of it. All this footer I don't need. Okay, better. Good. So we want to create the, let me see. This is the content. This clouds, I think here maybe. Awesome counter. Let's see if I can make it 2 in a row without any mistakes. No, I don't. Oh, well, it's not known. That's true because we haven't imported the right stuff yet. Okay, we need the app module. And in here will be importing the Angular statements. So the custom element schema from Angular and the defined custom elements from the stencil component. And then we define the custom elements to the window. However, we need one more thing here. That is, yep, I think I did this right. We need to tell Angular to use this schema as well. Now, if all goes well, here it is. How awesome is that? And again, same as with the React application. If you have like 100 components, this is all you need to do. You only need to import it once and you can use it anywhere, everywhere, anytime you want. So I think that's pretty nifty. Yes, a web component can be very easily made. It can be, well, it's not very much work, but frameworks or even non-frameworks can have their use as well. So I guess that's my side of the story. So I guess back to you, Wishy. If there isn't too much of a lag in sound, we can have a conversation.
It looks normal. Thank you for presenting, and it has been really insightful to see how web components work in different libraries or frameworks. I especially like that you lit up a little bit of our internal debate about which framework or library is better, like React versus Angular. I do have to agree, React has a better starting page, so I give you that. But Angular is still my preference. We have some room for questions, and I noticed that we missed one of the questions. It was actually meant for Ton, but perhaps you can ask this or provide an answer to this question. And this question comes from, I'm sorry if I mispronounce your name, Joel Garrier. He says the following: due to the SEO constraints, would you say that web components would work well on-premise or private portals?
This is a question for me.
If you can answer this, of course. Otherwise, we can hand it over to Tom.
Well, obviously, on-premise or private portals doesn't have to. Well, CEO is not as much an issue for private portals as for public domain websites. Yeah, I'm currently working for the Dutch police, and obviously we don't have an open source framework like ING does. It's very close to the police. It's internal only at the moment. We might be going external with it, but I'm not sure if I can even say that out loud. So, but if that's the case, then yes, we'll be having discussions about how to best implement it because of the SEO constraints for big public websites. Yeah. I'm not sure if that really answers the questions, but I think it's a good story.
All right, I think that will answer the question. We can move on to the second question, also from the same user. Do you have to specify an opening and closing tag, or can it be set to be used as a self-closing tag?
That's interesting because when Ton was doing his presentation and it wouldn't show, at first I thought because you have to use a closing tag and you can't use self-closing. I always thought that was the case, but Ton has proved that you can use self-closing tag. So maybe that's some new development. I'm not sure. I always used to think you need a closing tag. Otherwise, well, at least if you're going to use slots, which Ton showed the slot for the counter title. If you'll be using slots, obviously you need a closing tag, because a slot is anywhere between the opening and the start and the closing tag. But it does appear that you can have a self-closing custom element.
And would you like to add something to
Yeah,
it?
no, so I think it's both possible, as Maarten already mentioned. For slots, you always need to have a closing tag, because otherwise you don't have anything to put something in between. But it's possible to use self-closing tags. Actually, I do know that with some linting configurations, it's actually not allowed to have self-closing tags. So then probably your editor will give you some sort of violation saying, yeah, you really need to close your HTML tags. But I think that's more of a linting issue than it's actually an issue that it will not work or something like that.
Okay. All right. And then moving on to the third question. Can the public and private methods have the same name? That's a question directed to Maarten.
No, they
That's a
cannot.
short answer. Then a follow-up question. Can the public method be called internally?
Yeah. Yes. That's yes. You can basically it's like any other class. The private methods are only accessible internally, and the public methods are well, both internally and externally. So yes, you can use them internally. You have to keep in mind in some cases that for instance, in the Stencil web components, you need to make a public method asynchronous, and it might be that you need to use a promise for that if you use it internally as well.
Interesting. Yeah, I'm looking through the comments. I don't see any questions. I think we're quite, let's take it in. And then if you have any questions, you can always put them in the comments, of course. Yeah, I would like to thank you all for listening, and also thanking Ton and Maarten specifically for presenting. I do want to say, I want to come back to the first thing that I mentioned about this hoodie giveaway. We were going to show you a QR code right now, but we'll also post it in the chat. If you scan it, you will see a question, and if you fill in, and well, we will select one of you, unfortunately, but then this hoodie will be yours. So take your time, and hopefully you'll find the answer. Yeah, unfortunately, I have to conclude this tech talk, but don't you worry, we'll come back. On the 10th of May, we have the next Build Tech Talk, and that talk is about software testing in the airline business. So stay tuned, you will hear more about it. Thank you. Bye all.